Today's lesson's on limiting reactant and excess reactants. We've been looking at, in Chapter 12, some mole-to-mole calculations. We've learned how to go from moles to moles mass to moles, and also from mass to mass. Now, we're going to now take those skills and bring them together with the concept of limiting reactant and excess reactant. Now, a reactant, remember, those are the substances in a chemical reaction that are reacting with one another. As they collide, bonds are broken, products are formed. So, in a chemical reaction, there is at least one limiting reactant, and then there's going to be an excess reactant or reactants. The limiting reactant does exactly what it sounds like. It limits the amount of product you can form in a chemical reaction. So it's the reactant that runs out first. So therefore, when it runs out, you can't produce any more product. So the limiting reactant is a reactant that controls how much product will actually form. And if you're in industry, like a chemical engineer, it's important that you're able to understand which of your reactants is your limiting reactant, because bottom line is when that reactant runs out, you can't produce any more product. And if you can't produce any more product, you won't make any more money because you're trying to sell the products, right? So if, for example, you're producing fertilizers, or if you're producing perfume, or whatever it is you might be producing, the reactant that runs out first is a very important reactant in that chemical reaction, because if, bottom line, your money, the money you bring in, your profit is controlled by how much product you can make, if you let your limiting reactant run out, that reactant runs out, you make no more product, and therefore you make no more money. Now, the excess reactant is the reactant or reactants that there is too much of or more than enough of. And so some of the excess, we call it excess or extra, will be left over. So this will be like where you have some extra left over that is unreacted. Now, before we look at an actual example, I want us to think about a recipe. You know, in this chapter, I've drawn an analogy for the chemical reaction. We talked about the bowl bridge, and I said a chemical reaction is very much like a recipe. So if we consider this quote-unquote reaction for making a peanut butter banana sandwich. How many of you have ever tried one of those? Peanut butter banana sandwich. So here's the recipe, okay? So to make one sandwich, you would need 2 tablespoons of peanut butter, 4 slices of raisin bread, and 1 banana. That, when put it all together, you would make the perfect peanut butter banana sandwich. So let's take this recipe and let's write it so that it looks sort of like a chemical reaction. So let's see what that would look like. If you were to write that so that it looks sort of like a balanced chemical reaction, you would write 2 tablespoons of peanut butter plus 4 slices of raisin bread plus 1 banana yields 1 sandwich. So this has 1 product, so it would be similar to if you were to have a synthesis reaction, right? A synthesis reaction. So you'll see in this example that I'm using that the reactants are the ingredients. Your reactants in your chemical reaction are your ingredients, just like the ingredients in this recipe. And then the product is the ultimate thing that you're making, the substance that's produced. So in this case, the product is the sandwich. So I'm going to take this recipe and I'm going to talk you through a calculation, if you will, that would be very similar to the kinds of calculations we will do in class to figure out which reactant is our limiting reactant. So let's kind of continue with that train of thought. So here's my recipe again: 2 tablespoons of peanut butter, 4 slices of raisin bread, 1 banana yields 1 sandwich. So let's say we're going to have a little get together, and so I go out to the grocery store and I purchase my reactants. I purchased my ingredients. And when I get back home and I'm ready to start making my masterpieces, um, I figure out that I have approximately 70 tablespoons of peanut butter. I have bought 200 slices of raisin bread and 40 bananas because when I went to the grocery store, I didn't really have a lot of time to figure out exactly how many I needed, so I didn't have any left over. So I just kind of bought up a whole bunch of the ingredients and just came home, and this is what I ended up with. So let's think about how could we figure out how many sandwiches we can make and which reactant is the limiting reactant. Let's just think about that. All right, so to do this, what you want to do is you want to take your ingredients and you're going to convert them all to the same product. So let's figure out how many sandwiches we can make. So we're going to take our givens or our ingredients, 70 tablespoons of peanut butter. I'll put PB for short. And remember, we're trying to make sandwiches. We're trying to see how many sandwiches we can make. So I'll put SW for sandwich. We have 200 slices of, I'll put SL for slices, of raisin bread. And finally, I've got 40 bananas. Okay. And again, we're trying to see how many sandwiches we can make. So we're looking at our chemical equation, and remember, we just learned how to figure out how to go from moles of A to moles of B. So let's kind of treat this like these were moles, even though they're really not moles. We're going to think of them like as if they were moles. So we need to get our units to cancel, right? Because we're using dimensional analysis. So we need tablespoons of peanut butter to cancel. So I'll put tbsp of PB here. And I'm trying to figure out how many sandwiches I can make. So what I'm trying to find goes on top here. So let's look at our equation. According to the recipe, one sandwich requires 2 tablespoons of peanut butter. Sorry, 2 tablespoons of peanut butter. So one sandwich to 2 tablespoons of peanut butter. So if I used every bit of the peanut butter up, 70 divided by 2, I would make 35 sandwiches. All right, so I can make 35 sandwiches, and when I make 35 sandwiches, all my peanut butter's gone. Well, let's see how much we can make with the bread that I've purchased. So I'm going to put slices of raisin bread on bottom. I'm going to put sandwiches on top. So to make one sandwich, I need 4 slices of bread because I'm going to make like a triple-decker sandwich, a double-decker sandwich, okay? So 4 slices of raisin bread will make 1 completed sandwich. So 200 divided by 4, that's going to give me 50 sandwiches I could make with all of my bread. So if I used every slice of bread up, I would have made 50 sandwiches. And now finally, we need to see how many sandwiches we can make with our bananas. So put bananas on bottom, sandwiches on top. So one sandwich requires only 1 banana, so 1-to-1 ratio. So that will let your bananas cancel. So 40 times 1 divided by 1 gives me 40. I can make 40 total sandwiches with all of my bananas if I use every banana up. So let's recap. My peanut butter will allow me to make 35 sandwiches. With the raisin bread I bought, I could buy 50 sandwiches. And with the bananas I bought, I could make 40 sandwiches. So the question was, how many sandwiches can I make? Well, look, I can only make 35 sandwiches, y'all, because once my peanut butter runs out, I can't make any more peanut butter banana sandwiches. I could make just a plain bread and banana sandwich, but not with the peanut butter, right? So the way that we know who the limiting reactant is when you convert all of your reactants, all of your ingredients to the same product, whichever one makes the least amount is your limiting reactant. So you would say that the limiting reactant, I'll say the LR, is the peanut butter. because that's going to run out first. It controls how many sandwiches I can make ultimately. And the excess reactants, I have two of them. I'm going to have some excess bread, raisin bread, and bananas left over. So that's pretty much it in a nutshell. So let me talk you through that. We're going to write down exactly how to figure out the limiting reactant. So in order to determine which reactant in a real chemical reaction is your limiting reactant and which is your excess reactant, you're going to convert each reactant to moles of the same product. Think about what we just did. We converted each ingredient to moles, well, really not moles, but to the same product, sandwiches. Now, if you have a reaction that has more than one product, we're going to always use the first product that's written in the chemical reaction so that all of our answers are always going to match and there's never any confusion. So convert each reactant to moles of the same product, and we're going to always go to the first product. Now, what do we do next? After we had converted to moles of the same product, the reactant that produced the least amount, the one that made the fewest sandwiches, right? 35 sandwiches. The one that made the least amount of moles, that was your limiting reactant. Remember, the limiting reactant controls how much product you can make. So it determines the maximum amount of product possible to form. When the limiting reactant runs out, class, no more product can be made. So the reaction comes to a screeching halt. And unless you go replenish that reactant, so unless I were to go back to the store and get some more peanut butter, I couldn't make any more sandwiches. All other reactants are considered the excess reactants. So we call them excess. Now, if you want to call them ER for excess reactants, that's fine. I use X and S for excess for short as well, but either is fine. In our next lesson, we're going to look at some actual examples.